Hello and welcome to the 6WIND demonstration that shows how OpenStack environments benefit from integrating 6WIND Virtual Accelerator with Project Calico's Layer 3 virtual networking solution. We demonstrate the performance gain by comparing Calico performance with 6WIND Virtual Accelerator versus standard Calico and Linux. In addition to boosting Calico L3 throughput, we demonstrate 6WIND Virtual Accelerator's ease of installation in OpenStack environments and transparent operation with zero modifications to Calico or OpenStack. The demonstration has two parts. In part 1, Calico is deployed in a standard configuration with no acceleration on two identical compute nodes comprised of a Red Hat OS running on an Intel Xeon E5-2690 V3 processor with 12 cores and one 40 gig interface used for testing. A single CentOS VM resides on each compute node. For IP throughput testing, we deploy and run the iPerf benchmarking application on both VMs. Next, we deploy the Apache Bench benchmarking tool and the Nginx web server on compute nodes 1 and 2, respectively, to determine the HTTP request rate. In part 2, we use the same base configuration and integrate 6WIND Virtual Accelerator into the hypervisors, and note that Calico requires no modifications. We run the same IP throughput test and the same HTTP request rate test. Before the testing, we confirm that Calico and Bird, IP control plane application, are installed in the compute node. We will only check one of the compute nodes, and the OpenStack version is Mitaka. Let's start the part 1 configuration. On the control node, we will create the networks required for tenant connectivity and a CentOS VM on each control node. Instead of encapsulation and overlay techniques, Calico uses routing and access control lists to connect, isolate, and provide access to the tenant's VMs, regardless of the subnet in which they reside. Everything is set to start the IP throughput test, and we invoke iPerf on each VM. The Calico standard configuration with no acceleration can forward 14 gigabits per second of data traffic across a 40 gigabit per second link. Next is the HTTP request rate test, and we deploy and start the Apache Bench tool and the Nginx web server on the CentOS VMs.
The HTTP request rate for the Calico standard configuration with no acceleration is 17,900 requests per second.
We move on to part 2 of the demo. On the control node console, we delete the VMs and move to the compute node consoles to install 6WIND Virtual Accelerator. We'll install the authentication credentials, and then we will download 6WIND Virtual Accelerator from the online repository. We use the standard Linux package manager to install. As far as configuring cores, we use zeroconf, the default configuration which dedicates one CPU core to 6WIND Virtual Accelerator. We enable and start Virtual Accelerator and restart libvirtd and OpenStack Nova compute services. We are almost done. We install the OpenStack extensions to the Nova compute configuration to exclude the cores dedicated to 6WIND Virtual Accelerator FastPath. Lastly, we restart OpenStack Nova compute services one more time.
With the installation process now done, we confirm that Virtual Accelerator installs easily, and we confirm its transparent operation since Calico required no changes. We are now ready to create the VMs. At the control node console, we create one VM using a huge pages flavor on each compute node. We execute the IP throughput test. The result is 23 gigabits per second, or 2 times the Linux performance. Next, we execute the HTTP request rate test. This results in an HTTP request rate of 61,300 requests per second, a 3 times increase over the Linux rate. We have reached the end of the demo. In summary, we demonstrated 6WIND Virtual Accelerator improves Calico performance by increasing IP throughput and HTTP requests per second by 2 times and 3 times respectively. In addition, we showed 6WIND Virtual Accelerator easily installs in the OpenStack environment and requires 0 changes to Calico, proving Virtual Accelerator operation is transparent to Calico. That is all, and thank you for your patience.